In question number 4, we know that it's talking about an arithmetic sequence, and we're going to start paying attention to that vocab so that we can get used to picking up on the clues. Because this is arithmetic, it's tipping us off that we must be dealing with an adding or a subtracting pattern. They're giving us an equation, but they're not telling us anything specific. So it's up to us to interpret this equation based on patterns we've made before. One of the most helpful things that we can do is look back at our work from question number 1. Remember in question number 1, we looked at lots of equations like this one? The first thing we noticed was that the adder, because remember we're arithmetic, so we're adding something, was always the number attached to n. Minus 4 is attached to n. The minus sign makes me think of negative 4. So this sequence must be adding negative 4, or subtracting negative 4. That's giving me a big hint. When I'm doing this table, whatever is going to be there, I know that the pattern is going to be minus 4, minus 4, minus 4 every single time. So that's a nice hint that tips me off about what to do. Now besides the adder, the other important number given in the equation is always the initial value. Well, by definition, if the adder is the negative 4, the other number must automatically be the initial. So this is telling me that the initial value of this table, or this sequence, must be 10. And again, that gives me a big hint. That tells me what goes in the 0 spot in the table. So I know that that initial value, that 0 spot, must be 10. So let's think about it, and let's see if we can parse this question. It says in letter A, James and Carla are trying to find the third term in the sequence. So they're trying to go for this one here. I'll put a couple little stars to show that's what they're trying to do. James's suggestion is to fill in this table. And it looks like we have enough information to do what James wants. Carla says there's a faster way, and she suggests using the equation. So let's look at each person's approach individually. In the first part, it says fill in the table per James's suggestion. Let's think about James. James has probably identified that 10 is the initial value, just like we did. He probably figured that logically the minus 4 tells us to subtract 4. So he's saying, well, just keep subtracting 4 a few times and you'll get to the third term. You'll be done. Let's see if that works. 10 minus 4 would be 6. 6 minus 4 would be 2. 2 minus 4 would be negative 2. So it looks like the third term should be negative 2. And unless we made an arithmetic mistake, it looks like that seems to make sense. Now that didn't take that long. So if you're looking at the third part saying, okay, Carla's talking about a faster way, what could she possibly be talking about? I mean, this seemed to go fast. Let's see if we could figure something out. To be honest, even though it was kind of quick, we didn't really need this first term. We didn't really need this second term. The only question that we wanted was the third term. We had to get a couple of steps in between to get there, but those steps in between didn't really count. The answer to the actual question was just the negative 2, not the 6 or the 2 that came before it. So Carla must be talking about a way to get directly to this answer without needing those middle steps. Even though those middle steps are kind of easy, she's probably thinking we could skip those middle steps. She suggested using the equation. So let's think about the equation. I'm going to copy it just so I have it in this answer space. T of n equals 10 minus 4n. Now, because we wanted to find the third term, this is where Carla might have been thinking a little bit more logically. If I want the third term, the word third, and I'm going to write this in a color so you can see it, means n equals 3. Remember we saw that in a table on the previous page? The third term is when n equals 3. Just like the second term is when n equals 2, or the first term is when n equals 1, or the initial term is when n equals 0. So the third term is when n is 3. Is your algebra brain kicking on here? Because some of us might have immediately thought, oh, wait a minute, n is 3. I can just substitute that. I can do a little bit of algebra. I can plug in 3 into that n spot. If I do that, technically, I'm also plugging it in on the left, but nobody really cares about the left. That's just a formality. I'm doing 10 minus 4 times, instead of n, plugging in 3 for the third term. And that means I have 10 minus 4 times 3 is 12. 10 minus 12 is negative 2. And sure enough, That negative 2 is the same negative 2 we got from doing it James's way. So both ways are actually super helpful. Both ways work. And there are certainly benefits to doing it both ways. James's way was really easy if you can quickly subtract 4 in your head and if you can make a little table. Carla's way is really great if you can just quickly plug in the single number that you need and do the algebra. So both ways are wonderful, and it's up to you to decide which way works better for your brain. Now in letter B, it says to think about the most efficient way to find the 16th term. I'll be honest with you, there's no best way to do this. Some people will actually think that the easiest way to find the 16th term is to just stretch this table off the paper, maybe even like onto scratch paper, and they'll just keep going. They'll do the 4th term and the 5th term and the 6th term and the 7th term and the 8th term all the way down to the 16th. Some people would say, no, that sounds crazy. That's way too much work. I don't want to do that. And they'll take the 16 and do it Carla's way. They'll plug 16 into the end spot in the equation, and they'll get the equation to do the work for them. Everybody is going to be different, so you're going to have to decide which way works better for you. The last question, the value of the 97th term, requires a little bit of practicality. It can be argued that you can probably extend this table pretty far and probably do it in your head up to a certain point, but I'm not sure if anybody has the tolerance to stretch this table all the way out to the 97th term. So I'm starting to think that for letter C, Carla's approach might be better. Let's take n is 97 and plug it into the equation instead of stretching the table and doing it James's way, which just might take too long. In any case, see if you can decide which way makes more sense to you. And if you have the patience, you can do whichever one of these approaches you want. Even if that means you write out 97 spots in a table and do all of that and extends off the page, more power to you. But you decide. That's the last thing that I want you to really try to process today in this lesson, is just how your brain thinks about patterns. Once you know how you think about patterns, it's going to make the next lessons easier. So take some time to really make sure this idea marinates, take some time to make sure it makes sense, and then once you feel like you have a good understanding, you'll be ready for the next lesson. In between now and the next lesson, if you need to pop into office hours or send an email or text somebody to have them explain it in a different way, do that. Because this is so important for our foundations that I don't want you to have to work on the next lesson and so on until this one makes perfect sense.